Hello everyone, welcome back. Thank you very much for joining this channel and welcome to lesson number 4 from the Spring Security Fundamentals course. We discuss about the authentication provider today. Don't forget, if you are watching the event live, you have a live chat there. You can ask questions in the live chat. If you watch the event recorded afterwards, you can still ask questions in the comment section, or you can find me on LinkedIn or Twitter and you can ask me the questions there as well. So we'll continue the discussion again with the authentication provider, and to have a refresher for you, let's discuss very fast on the basic architecture of Spring Security that we took from the first lesson up to now. And you know that in this diagram we represent a request that is intercepted by an authentication filter. We know, but we didn't discuss the details yet, that this authentication filter is actually part of a filter chain, and this is something that is coming in one of the next lessons. But you know that the authentication filter intercepts the request and delegates the authentication responsibility to an authentication manager. And now we'll see a little bit more in detail the connection between the authentication manager and the authentication provider, because this is what we discussed today, is the authentication provider. And you will see that basically you can have more than one authentication providers, and the role of the authentication manager is to delegate the authentication responsibility to the proper authentication provider. It's actually finding the authentication provider that can help with a specific authentication type. This is because in your application you might have multiple ways to authenticate, and the authentication provider is the object that implements the authentication logic. So when you have multiple ways to authenticate, you will have multiple authentication providers, and each of the authentication providers object that you register for Spring Security implements a specific logic for authentication. So when the request is intercepted by the authentication filter, a specific kind of authentication is created, and based on this authentication, the authentication manager has to find the proper provider. And say we have an authentication provider, and the authentication manager will find an authentication provider to match that specific authentication. What happens is that then the authentication provider takes the responsibility of executing the authentication logic, and this is where, if you remember, if users and passwords are involved, this will delegate the responsibility for finding the user as well as verifying the password to other components. Mainly in case of Spring Security, finding the user is done through an user detail service, and the password encoder is the component to which the responsibility for validating the password is delegated. So the authentication provider delegates these two responsibilities of finding the user and verifying the password, usually to a user detail service and the password encoder. These components, we have discussed them in detail in the previous 3 lessons, and this is where you have seen how a user is represented in Spring Security, because we have discussed plenty on the user details contract. You have seen what the user details service contract is. You have seen and you have learned and applied a user details manager as well, and we have discussed the password encoder. And in this lesson we'll go further, and in this diagram we will discuss about the authentication provider and how you use the authentication provider. So if the user detail service and the password encoder are not necessarily mandatory in your architecture, for example, you might have situations in which the authentication is not done through a user and the password, then you won't have these components. But you will always have an authentication provider that implements the authentication logic. So that place in which which decides how is the user authenticated is basically the authentication provider. So this is a component which will never miss from the architecture for authentication. And this is why it's a really important component that you need to understand, and you need to know how to create your custom authentication providers, because there will be situations in your real world scenarios where you have to implement a custom authentication logic, and that's done through an authentication provider. That's done by implementing a custom authentication provider, and that custom authentication provider set into your architecture will allow you to have a specific authentication logic. Thank you very much for your appreciations as well, and for your questions. Don't forget you have a live chat there as well. You can ask me questions during the live stream or after the live stream in the comment section. Okay, now that you remembered the basic architecture, let's go further and get our hands dirty and code an authentication provider. And in this video we'll only learn how to declare an authentication provider, but in the next lesson I plan to show you how to have multiple authentication providers. But to have multiple authentication providers, you will also have to learn more about the filters and the filter chain. So we will today discuss about implementing a custom authentication provider, and then you will learn more about the filters and the filter chain and authentication filters. And afterwards I will show you how to have multiple filters and where multiple authentication providers might be needed and how to implement them. And of course, in the end, we will decide on how to implement a specific security context management, and you will see that the security context can as well be customized somehow. This is basically what we need to do before going deeper into specific authentication types like OAuth. That being said, I have already opened an IntelliJ here, but I didn't create a separate project. You see, I have still here opened the project from the course number 3. I have to create a separate project for our custom course. I have decided to do that together with you now to see again the dependencies. Basically, I will only add the web and the Spring Security dependency. For this example, ours today, we don't need a custom database. So I will create a new project and I will use my Spring Initializer option here because I have an IntelliJ Ultimate. If you have a community version, you won't see this option, but you can still use the Start Spring IO to create your project in this case, or you can use another ID of your choice, of course. And then the same thing you will do, you will have to select your dependencies. Okay, first let's give it a group ID and a name. So it was Spring Security course number 4, and again I always in my examples use the latest version of Java because I can. Yeah, this is for the moment the latest general available version 13. We are looking forward soon to see version 14. And we go to select our dependencies. We only need the web dependencies for our endpoint, which we secured, just a dummy endpoint we use to our proof here. And the security, Spring Security, here it is. Again, no database in this example, no other kind of fancy connection, just a simple example to show you how to implement an authentication provider and how an authentication provider works. So we go and press the button next and finish the creation of our project. Wait a little bit for the dependencies to be loaded and downloaded by Maven in my case. Close the other window, why not, because we don't use it, and get into our application development. Still a little bit more to synchronize, but I'm sure it will be fast. Now, yeah, already finished. And the first thing to create is the endpoint because we need something to secure. So let's create a separate package that I call, as usually, controllers. And in the controllers package, the hello controller class, which is only a very simple REST controller and exposes a dummy endpoint for our example. And don't forget that I'm still using get mappings here, and if you go back to lesson number 3, you will see that I I have actually used the post mapping at some point to add a user, but I had to disable the CSRF protection, and we didn't discuss about that filter yet, and it will be in one of our future lessons. So that's why for the moment I only do use get mappings, and this way I don't have to get in touch with other kinds of configurations. I don't want to complicate the examples because I want to take them step by step so that you understand them very clearly. So this is why I only create a get mapping for the moment. Again, in the future, in one of the future lessons, you will learn how to use post put delete as well, but because we didn't discuss yet about the CSRF protection and the filters, we can't discuss about that now, and I don't want to complicate your example, so let's keep it with a get mapping. So I have a get endpoint, and this is the endpoint I need to secure. And from lesson 1, you have learned that only because I have added the Spring Security dependency, Spring Boot now auto-configures my project and creates a user detail service, a password encoder, and sets up HTTP basic. I will use HTTP basic further, but I would like to have a custom user. So you have already learned how to create a custom user, but let's take that again in and create a configuration class where we write our own implementation of we don't actually write, sorry, where we set up our own implementation of user detail service. I will use an in-memory user detail service because you have already learned in the past 3 lessons how to customize and how to work with other kinds of user details service and user details manager, and you have learned even how to create your own. So for our example, it's not really important to get into details anymore with this, and I will only use for that for this purpose an in-memory user details service. So create the configuration package, and in the configuration package create the project config class, which in my case is the only project configuration class. I use the configuration annotation to mark it as a configuration class, and then I will create a bin of type user details service, and this user details service bin, okay, bin, it should be annotated with the @bin annotation so that the returned instance goes right into a Spring context. And again, I only use here an in-memory user details service. So create a new in-memory user details manager, and in this one I will add only one user, which I will actually create with the user builder class in Spring Security. So if you don't remember or you don't know this, by the way, we are now discussing in lesson number 4, so you will find more details about this starting with the lesson number 1. So I'm assuming now that you know those things that we have already discussed in the previous lessons. That's why I'm going very fast through this. But if you don't remember them, you can anytime find the lessons recorded on this same channel, and you can use them to remember what these details are. So I'm only basically creating an instance of the very simplest user with a username, a password, one authority, and I use this builder class to create the user, which I will register to an in-memory user details manager. The in-memory user details manager is an implementation that allows us to store the users in memory, which is not the case in a real-life scenario. In a real-life scenario, you will probably use a JDBC user details manager, an LDAP user details manager, or you will create your custom user details manager as we've done in the past 2 lessons. So you can go back, and if you don't know what a user details service is, I have detailed a lot about the user details service and the user details manager contract in the past lessons. Now, because I have registered my user, I can return the instance of user details service, and Spring Security will have now this user, and I can use this user to call my endpoint. But in order to be able actually to call the endpoint, I have also to specify a password encoder. And again, because I'm creating a very simple example, I'm still using the no-op password encoder, which is basically a password encoder that's not hashing and not encrypting anyhow your password. That's why you will never use it in a real-life scenario, so avoid this in a real-life scenario. This is only for examples, demonstrations, and proof of concepts. So that being said, at the moment, I have created my user details service and I have created my password encoder. And again, if I would run now my this example, it will work because I have by default an authentication provider that is declared and configured by Spring Boot. But what we want to do now is to go one step further and learn how to create our custom authentication provider and understand what this contract is all about. So this is what I'm actually doing now. Instead of working with the default configuration, I will create my own configuration to use this user details service and the password encoder. So I will basically recreate the logic that I already have. But with this, I hope I will make you understand clearly what and how to use an authentication provider. So that's why I'm now creating a separate package. I will call this package security, and inside I will create a class called the custom authentication provider. And the custom authentication provider is an implementation of the authentication provider contract, so it implements authentication provider. The authentication provider contract represents again that object in Spring Security that implements the logic for authentication. So in our case is that if and else that tells us if the user exists and the password is correct, then the login should be successful. Otherwise, the login should fail. So this is exactly the logic we want to implement here. It's a very, very simple logic based on the user details service and on the password encoder. If the user exists and the password is valid, do the authentication, otherwise fail the authentication. So yes, of course, we need to override the authentication provider methods, and we have two methods that we need to override. They are called authenticate and supports. They are the two methods part of the authentication provider contract and the two methods that you need to understand when configure and implement and configure an authentication provider. So what are these two methods actually? Well, the authenticate method is basically the simplest. It's where you implement the authentication logic. So I will write it for the moment here like this. Here you implement the authentication logic. This is what you do inside the authenticate method. How does this work? So the logic for the authenticate method should be very, very simple. There are three situations. One in which you authenticate the user. So in this case, if the request is authenticated, you should return here an authenticated, or how the documentation says, it's actually a fully authenticated authentication instance. If the request is not authenticated, you should throw. And yes, you know what you should throw. It's part of the contract. Authentication exception. Any kind of authentication exception. And there is the third case where the authentication isn't supported by this authentication provider. Then you return null. So this is the way the authentication provider was designed for Spring Security. it has three branches, three possibilities. Its purpose is to authenticate the request. But we have the situation in which the authentication is done successfully, and then what you should return is an authentication object. We discuss immediately about what this object is. There is a case in which, of course, the authentication fails. Let's assume it's an authentication based on username and on password. Then if the username or the passwords are wrong, then you should throw authentication exception. And for the authentication provider, that means the authentication fails. If this authentication provider doesn't support the object that was provided, and again, I will detail this doesn't support, what does this actually mean immediately, then we return null. When we don't throw exception but we return null, so we return we don't return an instance of authentication, of fully authenticated authentication, and we neither throw an exception but return null, then what does this mean is actually that this authentication provider doesn't support, cannot decide if the authentication is proper or not, and then tells the authentication manager that it should try to find another authentication provider to do this logic. So this is what we should implement here. And then we have this method called supports, and that could be really confusing because we have already decided that the authenticate method should return null if the authentication isn't supported. Now, how was this designed is that you have this supports method, and this method is actually called by the authentication manager before trying to do the authentication by calling the authenticate method. So this supports, as you can see, as a parameter here only has the type. So only has this class is the type of authentication. So this parameter is the type of authentication. The type of authentication decides in the first place if this authentication provider knows or doesn't know how to authenticate this object. So for example, if we say here username password authentication token class equals this class here, maybe it's better to name it authentication type, just to be very clear. So this is the authentication object type. Okay, so if I say something like this, this actually means that the authentication manager, again this is on the diagram, the authentication manager will call my authentication provider only if it did receive from the filter the type of authentication called username password authentication token. By the way, this is the kind of authentication that is default used by the basic authentication filter. If you enter it, you will see that somewhere it extends an abstract class, and somewhere in its inheritance chain it is of course of this type authentication, which is exactly the type that you see here, authentication, which is the object that represents the authentication process in Spring Security. So now going back to the authenticate, it should implement the logic that decides if a request is or isn't authenticated. So it receives as a parameter an authentication and it returns an authentication. The authentication is an interface. It is the contract representing the authentication process in Spring Security. It is the authentication process before being authenticated, so before the decision was taken that the request was authenticated, but is also the process that has ended. So it's also the representation of fully authenticated, which is after the authentication provider decided that the request should be authenticated. As you can see here, two of the methods of this contract are is authenticated and set authenticated. So what happens? This method is authenticated should return false if the authentication provider didn't decide yet that the authentication should be that the request should be authenticated or not. So if is authenticated is false, it means that the process didn't end. We didn't decide if the request is authenticated, if it came with valid credentials or whatever that logic for authentication means. For example, if we are looking for usernames and passwords, as we do now, if the username and passwords are correct. So until we decide, the is authenticated should return false. Once we have decided, and when I say we, is the authentication provider, because this is the component implementing the logic. So once the authentication provider decides that an authentication is authenticated, which means that the process finished and the provider decided that the username and password are correct, or whatever credentials were presented are correct. It can be a token, it can be a key, it can be a fingerprint hash, whatever the logic of authentication means. When it finished and the authentication provider decides it's a correct authentication, it's a valid authentication, then it will set the authentication to true. So this one should return true, and that means that the authentication ended and the credentials were verified, were validated. Besides the result, besides if it is in progress or finished, the authentication, we also have the credentials, which is generally considered to be the password. Observe that this is returning an object, and the reason for why it returns an object is because the password is not necessarily only a string password. It might be a key, a private key, it might be something else. So the credentials are not necessarily usernames and passwords. It can be something different. It can be a cryptographic key, for example. Yeah. So that's why it's not always a string. It's an object. We don't know yet here what that is. Details, where you can store a specific object, where details are where you store details about a specific authentication. So we will refer back to this method a little bit later when we discuss the OAuth2 flow. That's where we basically use this method to set details on and get details from a JWT token. But again, that will be later in this stream. We still have a lot to discuss until we get to the OAuth. Then you have the principal, which is usually considered the user itself. And by the way, be attentive to the fact that this authentication interface from Spring Security also extends principle from the Java Security from the JDK package Java Security, where basically one of the most important methods is the get name. That's usually the username, and the authentication extends principle because this way it's easier and it's more flexible to maybe if you have implemented your application somehow else and you use the principle from the JDK, it's easier to simply have this contract a little bit more particular, and then it helps another implementation to go to Spring Security if they relate on the same way of representing an authentication as the JDK itself. So that's why this interface is extending the principle, and is not simply an interface of Spring Security that could have been clean without extending something else. So the idea is that the authentication contains all the details about the authentication, including the credentials. By the way, when you do implement your own, make sure that the credentials are not kept in memory after the authentication finished. It contains details, sometimes it contains details about the principal, and it contains the username, and of course it contains the authorities, what privileges are allowed after this authentication becomes fully authenticated. This collection being that collection of roles and authorities, let's call them in general privileges, that will be used in the authorization configuration afterwards. But let's get back to our authentication now. So only discuss about how to implement a custom authentication logic. We need a class that represents the authentication. We can of course anytime create a class of our own. Sometimes we need to create a custom class for our authentication. This is basically something that we will do in the next lesson. In the next lesson, I will show you how to create your own authentication. But for the moment, because we still use HTTP Basic, I know that HTTP Basic uses this username password authentication token as an implementation of authentication. By the way, its name suggests username password authentication. So it is an authentication based on a username and the password. It's clear, I think, enough to understand that this is an implementation of the authentication contract that stores somehow a username and a password. But again, because not all the times you have usernames and passwords, sometimes you need to even create your own authentication type. And again, in the next lesson, I will show you how to do that together with the way of registering more than one authentication providers. This is the plan. So the authenticate method gets an authentication. Through that, it gets, in our case, the username and the password. It has to do some logic, and once the logic is finished, it returns an authentication where the is authenticated should return, of course, true. If the authentication fails, again, an exception should be thrown, an exception of the type authentication exception. So how do we implement this? Well, we have started by saying that our authentication provider only supports this type of authentication. This method support is called before the authenticate method. So when the authentication manager tries to find a proper authentication provider, first of all, it calls the supports method. Imagine that the authentication manager has a collection of authentication providers. This is what actually happens in the end. Somewhere in the backgrounds, the authentication manager has a collection. Imagine it's a list, doesn't really matter. A list of authentication providers. And it parses this list and it calls the supports method first for any of them. If there is no authentication provider that supports that specific authentication which was delegated by the filter, then it will fail with an exception because there is no authentication provider that can decide whether the authentication should be valid or not. If there is one, let's say the authentication manager finds one implementation of authentication provider for which supports returns a true. For example, in our case, we know this will happen because we have the basic HTTP filter, and it's that filter using this exactly implementation. So in our case, when the authentication manager will get this kind of class, for us the method will return true. And then the authentication manager calls the authenticate method. When it calls the authenticate method, there is still a chance that the authentication provider refuses to use this authentication. Like it cannot, for some reason it cannot decide whether it's valid or not. Say you don't care about the type, but you care about some detail in the authentication itself. When I do an analogy for this, I usually say, let's imagine we have a door lock, like door locks in hotels sometimes have also a physical key and a card. So imagine you have that kind of a complex door lock where you can use a physical key or you can use a card to open the door. Let's assume then the physical key and the card are basically two kinds of implementations. So they will be implementations of the authentication contract, like in my case here, the username authentication token object. You will have a physical key, which is one kind of the authentication implementation, and you will have the card for the door, which is another kind. Now, if you base on the type, then you implement first the supports method, which will tell which authentication provider supports a physical key and will return true if the type of the authentication is a physical key, or will return true in case the implementation is a card. But then say we have multiple kinds of cards. Say we have a card that can be used by the administrators of the hotel, and that's a different, it's still a card, so as an implementation is a card, but it's a special card. It's different than the one that is used by the tourists, by the visitors, because that admin card can open all the doors, for some example. So say in this case we have multiple kinds of cards, like two kinds of cards. The method supports will return true for both of them because both are cards. Then if the authentication cannot decide based on that specific instance of cards for some reason, it is a card, so it is supported by the specific authentication provider, but somehow for some reason that exact implementation of card is not supported, and the authentication provider cannot decide if it is a valid or not card, then it will return a null. Null means, yes, I do support, the supports method tells I do support this type of authentication, but for this specific instance I can decide. And because I can decide, I won't return a fully authenticated instance. I won't throw an exception because I don't know if it is neither valid, neither not valid. So I will return null. What will the authentication manager do in this case? The authentication manager in this case will get the null, and that will mean I need to find another authentication provider. So when the authentication manager, instead of receiving an object and neither an exception, it receives a null, it will continue looking in its collection for another authentication provider that it might decide on the authentication. Of course, if it doesn't find in the end any authentication provider, then it will fail. It will completely fail with an exception, and the authentication doesn't work. But if it finds an authentication provider in the end, it has that authentication provider which decided will either return an authentication instance or will throw an exception. And that's what we want now to do here. So what I will basically do now, I will keep your comments here, so you will find them on my GitHub when I upload the project, and you can remember faster what we have discussed in this lesson. But I will also implement the logic. So I have already implemented the supports method, knowing the fact that the HTTP basic uses this type of authentication. Maybe you wonder, where do I know that from? I just know. So if you look into the basic authentication filter class, you can find that yourself. So it's just, I just looked in the class sometimes ago, long ago, and I know this happens. I know the type of, see, this is the type, that the basic authentication filter, which is the default filter. Again, we didn't discuss filters in details, but it's part of one of our next lessons. So that's why I'm using here this type. And now I should only make sure that this is a component in the Spring context, so that I can, user details, I don't see, okay, user details service. So I need the user details service to find the user, and I need the password encoder to validate the passwords. So I auto-wire them from the context because I know I have put them in the context here in the configuration class. So that should be clear for me. And now what do I do? It's basically I will load user by username. I can take the username from the authentication itself, because I have the authentication which represents the request, has also the credentials of the on the requests that I have to authenticate. So that will be username is from authentication, usually get name, and then I have the password, and then I say authentication get credentials. Again, remember that getCredentials returns actually an object. So that's why I will transform it here into a string by calling the string value of method. So I have the username and I have the password, and then I can write my logic here. I will use the user details service to load the user by username. This should provide me a user details. So if you remember, the load user by username returns a user details, which is the contract that represents the user in Spring Security. And then I will have if a user exists. So maybe you also remember from the first 3 lessons that this method will throw an authentication exception anyway if the user doesn't exist, if it is correctly implemented. So in my case, theoretically, it's not really necessary to test for null here. So I will say something like this: if the user details is not null. But this is only to make sure that the implementation is correct. Basically, this method should throw an exception if correctly implemented, and I will never get here with a user null. We have implemented it ourselves, if you remember, in the previous lessons. But for the moment, I will consider also the case in which maybe the developer didn't implement it correctly, and I might get a null here. So I will have, in case I have a null, that means I throw a new bad credentials exception. Where did this bad credentials exception came from? Well, it's just an implementation of authentication exception provided by Spring Security. I can use it. Of course, I could have used directly authentication exception, but bad credentials exception tells me a little bit more of what happened if I see it in the stock. So I will throw this implementation of authentication exception, bad credentials exception, with generally in a real life scenario a proper message, not only error. I should say something more, but be very careful what that more means. Also, you also have to take into consideration not to leave too many details with the exception, just enough for you to be able to debug. And then further, I use the password encoder with its matches behavior, and I will say if the password matches the one I found in with the user details service, then I should return, and this is the place where I should create and return a fully authenticated authentication. So I have to use a class that implements the authentication interface, and in my case, of course, I will use the same class that I receive, which is username password authentication token. So I do create here another authentication. Let's call it A. And in order to create an authenticated username password authentication, I will use a constructor of this class that has 3 parameters. This one with the 3 parameters, which also has the last parameter is the authorities we allow. This is the one that automatically also sets the authentication as fully authenticated. You can see here that at the end of the constructor, it uses the set authenticated with the value true as a parameter, making this authentication an authenticated object. So that's why here now I can say username, password, and get authorities from the user that I have retrieved by the means of the user details service. And this is now my authentication, and I do return it from here. So the logic still the same that we have discussed at the beginning. The authenticate method returns an authenticated object of type authentication if the authentication is correct. In our case, if the username exists and the password is correct. Otherwise, if either the password is not valid or the user doesn't exist, it will throw an authentication exception, and that will tell the authentication manager and further the filter that the request didn't go further. So this is it, and now you can simply plug it into your configuration. You go to the configuration, To do that, you extend the web security configurer adapter class that we have already used previously. Be very attentive. You have to override one of the configure methods, but it is not the one we have used in the previous lessons. This time it is this configure with the authentication manager builder as a parameter. And its parameter has the method authentication provider, which allows us to specify an authentication provider that we would like to use. So I know my authentication provider is a component, so I can auto-wire it. You see here I have used it as a component, is annotated, is part of the Spring context. This is why I also was able to use the auto-wired here. That means that I can as well auto-wire it here. And provide it as a parameter. This is also how I would be able actually to add more authentication providers, because I've told you in our case we discussed about only one, but you can have more. The authentication manager is actually searching in a collection of authentication providers. So basically if you would like to have more, then you can simply just call it again here. You just call it as many times as you want and register more authentication providers. But again, we will do this practically in the next lesson. So for the moment we only have one, which is this precise one that I have here. And that's it. We have finished our example. Now you do use a custom authentication provider. You use this authentication provider instead of the one that you were provided with by Spring Boot at the beginning. So to prove that, I will basically put a breakpoint here and I will run it with debug, and I will try to call my hello endpoint from Postman and see that it will go here. If it stops in this breakpoint, it means that indeed Spring Security now really uses my custom implementation of authentication provider. So we run the example, we wait for it to start completely, and then we go to Postman and we try to call the resource. We can try to call it with both valid and invalid credentials, and you will see the results. So I go back, I create a tab here in Postman, and then I write the address. And I need a basic authentication. Let's say I have this user. Of course, this is not part of my users, so it should fail. If you go here, you run it, you can see that automatically IntelliJ stopped into the breakpoint, which proves that we do use now our custom implementation and is not the one provided by Spring Boot anymore. So we go here and you go here, and you can see that the username Emma was indeed taken from the request. The password 12345 was indeed taken from the request. And then the user details service most probably will fail with an exception because Emma doesn't exist in my in-memory user details manager. I didn't configure this user. I only have a user John. See, only John is here. So that's why when I go now one more step, I have an exception, and that will basically fail, and automatically the manager will tell the filter, and I will get back in my Postman a 401 unauthorized, which is expected. Then if you use a John, actually, you run it again. Yeah, we go further. I just completed the request, and you see for John it works. I have a 200 and I see here the result. But we knew this happened anyway. What's new from the previous lesson is that we have implemented our custom authentication provider. So that's basically what's different. And my hope is that you understood what this authentication provider actually is and its place in the Spring Security architecture. We know now a little bit more, and with the next lesson you will learn even more. You will see how to have another filter and then you will see how to use more authentication providers. So again, the flow, to conclude and go once more through the code, the flow is that the request is intercepted by the authentication filter. The filter delegates the authentication responsibility to a manager. The manager searches through a collection, through a list, let's say, of authentication providers, trying to find the one that matches to the authentication object. Remember that the authentication manager might have more authentication providers, and only some of them, or maybe only one or none, can understand a specific authentication. So authentication manager parses the collection of authentication provider, finds the proper authentication provider, first of all by calling the supports method, which is the way an authentication provider acknowledges it knows a specific type of authentication. So this method should be overwritten by you to return true for a specific type understood by this authentication provider. And then it might have the situation in which the authentication provider, even if it supports a specific type, it refuses that instance by returning null. Remember, we have the case in which even if the authentication provider supports actually a specific type of authentication, it returns null to tell the authentication provider that it doesn't support that specific instance for some reason. But if it does support, and assuming, say, the authentication manager finds the proper authentication provider, it should have now only two possible results. Either the credentials are okay, so like in my case here I have a username and a password. I just have used the HTTP basic and I use the username and the password. I took them. If they are correct, which means the username is known by the system and the password is valid, then we return an authenticated, a fully authenticated authentication, which is an instance of authentication for which the isAuthenticated method returns true. In our case, you can clearly see here I have this case created correctly because this constructor sets the authentication to be authenticated as well. Or it throws an authentication exception if either the username is wrong or the password in my case. So if the authentication fails, it throws an authentication exception. And yes, bad credentials exception is just an implementation of authentication exception. That's why I use it here. Once an authentication is done and is valid, we will see that the filter stores it in the security context, and that's the last step of the flow. So that being said, we have covered one more step, and next lesson we learn about how to create a filter and how to use multiple authentication providers. And then we go to the last step about the security context. And then we might say we completed the basic architecture of authentication of Spring Security. Then we discuss more about authorization, and then we go to the OAuth 2, and this is the plan for the next lessons. So I hope I will see you again next week with lesson number 5, and I really hope you have a good time for learning until then. Thank you very much for watching, and don't forget that you can ask me questions also after the video if you find me on LinkedIn or Twitter, or you can leave them simply here in the comment section of the video, and I will either reply you in one of the next lessons, or depending on your question I might need to create a separate video for you. So thank you very much again, and stay tuned for new videos.